Hi, welcome to the Explainer series for Quant. Here we'll be using very simple concepts and apply it to CAT level problems and solve them as easily as possible. In this session, we will look at quadratic equations, which are one of the most common test areas when it comes to the CAT QA section. We'll also be solving a few questions from past CAT, ZAT, and IFT papers, which came up from the quadratic equations area. I would suggest pause this video, look at these questions first. The link is available in the description of this video. Once you have tried these questions on your own, then proceed with the rest of this session. Please do share this with your friends who are preparing for CAT and other MBA entrance examinations. You can like and follow us on Facebook as well as subscribe to our YouTube channel to get live event and notifications for all the updates regarding CAT and other MBA entrance examination. You can also look at our WhatsApp as well as Telegram lists. You can join over there and we will update you. We don't spam over there. If you want, you can enroll for our Quant and LRDI courses. These are the best and the most comprehensive courses available in the market. Quadratic equations are a favorite of the CAT examination. They are as common as questions from circles and triangles in the geometry area. Every paper you will find 2, maybe even 3 questions which are related either directly or indirectly to the quadratic equations. Now, the general form of a quadratic equation is ax squared plus bx plus c equals 0. Now, key determining factor is a cannot be equal to 0, because if a becomes 0, then it will no longer be a quadratic equation. Right? The general form of finding the roots is x should be equal to minus b plus or minus square root of b square minus 4ac divided by 2a, where a, b, and c are the coefficients of x square, x, and the constant term respectively. Right. The nature of the roots is usually determined by the discriminant, which is b square minus 4ac. We'll come to this discriminant a little later in this session today. Right. Start off with something which came up in CAT 2017, slot 1. This one says if x plus 1 equals x square and x is more than 0, then what is the value of twice of x to the power 4? So from this, we'll find the value of x, eliminate any negative roots if there are there, and then from x find x square and then twice of x to the power 4. That is your path. Let's figure this out. So you'll have x square minus x minus 1 equals 0. Now we cannot directly factorize this. We can use the general form of finding the roots. So you will have x should be equal to 1 plus or minus square root of 1 minus 4 into minus 1, right, divided by 2, which will be 1 plus or minus square root of 5 by 2. Now 1 minus root 5 is negative. We don't want negative roots, so we'll just take 1 plus root 5. Now x square will be square of this. Right, so this will give me 1 plus 5 plus 2 root 5 divided by 4. Right, that will be 6 plus 2 root 5. When you divide by 2 throughout, it will be 6 divided by 2 will be 3. 2 root 5 will just give you root 5 divided by 2. That will be x square. Now, x to the power 4, we need 2x to the power 4 will be twice of this square. So 3 plus root 5 by 2 square. This gives you, one of the 2's will go out, so it will be just divided by 2. Right. So this will resolve to half of 3 square is 9 plus 5 plus 6 root 5. Right. 9 plus 5 is 14. 14 divided by 2 is 7. 6 divided by 2 is 3. 3 root 5. 7 plus 3 root 5. Option D is your correct choice. Okay. Next one is from IFT 2010. This is almost like a self-referential question. Now instead of a square minus ax square plus bx plus c equals 0, you have changed the form of the quadratic equation. You have bx square minus 2ax plus a equals 0. What will be the roots of find the root of the quadratic equation? Okay, so let's use the generalized form again. So if I rewrite this to ax square plus bx plus c using the form b square plus minus b minus b plus minus square root of b square minus 4ac divided by 2a, if I use the terms over here, you will get 2a plus or minus square root of 4a square minus 4 times ab divided by 2b. This will be your value of x. Now if I take 2 common, this will go out. 4a square, when you come out, it will be 2. This will also be 2. So this is out. So you'll get x should be equal to a plus or minus square root of a square minus ab by b. Now, unfortunately, if you look at it, here the denominator is not rationalized. The numerator has been rationalized. Usually we have a rationalized denominator and an irrational numerator. Here, if you look at it, the denominator is of the form an irrational form. So we need to make the denominator irrational again. So again, I'll multiply with the conjugate of this. So conjugate of this will be a minus plus square root of a square minus ab divided by a minus plus square root of a square minus ab. What do I mean by this is that if you have a positive sign here, you will multiply it with the negative sign here. If you have a negative sign here, you will multiply it with the positive sign here. So this will result in x will be now a square minus square of this. So that will be a square minus ab, right, divided by b into, this will be a plus minus square root of a square minus ab. Right, a square and a square will get cancelled. This will be plus, so one of the b's will get cancelled. So this will result in a divided by a plus minus square root of a square minus ab. Now we want a square root in the numerator also. So let's divide numerator and denominator by root a. Both numerator and denominator by root a. So this will give you root a divided by root a. Then if you take a root a common, this will be plus minus square root of a minus b, right, which is option C. It's a very interesting way of representing the question. Not very difficult. The complication will be when you usually have a square plus b, ax square plus bx plus c, and you try to confuse. That will sometimes get confused. Second part of problem of this was usually the numerator is irrational, denominator is rational. Here the denominator also has to be irrational. Now, just by looking at the discriminant, we can actually find out the nature of the roots of a quadratic equation, right? If assuming a, b, and c are real numbers, and this is very common in data sufficiency sort of questions, which you get in GRE and GMAT, where they play along with a, b, c might be rational or irrational by itself, or not real. So only for real numbers, when a, b, and c are real numbers, if the discriminant is positive, roots are real and unequal. If discriminant is 0, roots are equal and real. If discriminant is less than 0, then roots are unequal and imaginary. Imaginary roots are conjugate. So if one of the roots is a plus ib, the other root will be a minus ib. Right. Now, using this, we can solve the remaining 3 questions. Right. The third one is from CAT 2019, slot 2. Right. This also has some application of logarithms. Right. It says a be a real number, then the roots of this equation are real and distinct if and only if. They have to be real as well as distinct, which means the discriminant has to be more than 0. Greater than equal to 0 won't work. It has to be greater than 0. Right. So let's find the discriminant. This will be 4 square minus of 4 times log 2a. So minus of minus will become plus. Right. This should be greater than 0. Right. So in other words, this will be 16 plus 4 log to the base 2 of a should be greater than 0, or 4 times log to the base 2 of a should be greater than minus 16, should be greater than minus 4. Right. So which means a should be greater than 2 to the power minus 4. 2 to the power minus 4 is 1 by 16. Right, so A should be greater than 1 by 16. Option C will be our correct choice. Pretty straightforward. The next one is from CAT 2003, the leaked paper. The leaked paper which was repeated. Let's see what this says. If A and B belong to the set 1, 2, 3 and 4, then the number of equations of the form ax square plus bx plus 1 having real roots is how much? Right. So we know that roots of this equation would be based on your discriminant would be b square minus 4a. Right. For the roots to be real, this has to be greater than or equal to 0. In other words, b square has to be greater than equal to 4a. Now, the constraint is that both a and b can take only these values 1, 2, 3 and 4. So the value of b square will be 1 square, 2 square, 3 square, 4 square, which is 1, 4, 9 and 16. Now 4 times a, depending on 1, 2, 3 and 4 will be 4, 8, 12 and 16. Now to satisfy this relation, if I put b square is equal to 1, there is no value of a which satisfies. If I put b square is equal to 4, the only value of a which satisfies is when a is equal to 1 and 4a is equal to 4. So one relation which will satisfy. For 9, similarly, 4a will be 4 and 8, 12 and 16 won't satisfy. So two values of a will satisfy. For b square is equal to 16, all the 4 values will satisfy. 4, 8 and 16 are all less than or equal to 16. So all the 4 values will satisfy. So total possible equations will be 0 plus 1 plus 2 plus 4. That is 7 possible equations. So to give you an idea what the equations would be. So if I put b is equal to 2, a will be equal to 1. So you'll have x square plus 2x plus 1. This will give you equals 0. This will be one equation. If I take b is equal to 3, a can be either 1 or 2. So you can have x square plus 3x plus 1 equals 0, or 2x square plus 3x plus 1 equals 0. So you'll have 7 equations of this form. Obviously, I'm just trying to elaborate this. No need to do all this. Once you have gotten this, you can directly mark the answer. And the last one is from CAT 2005, but it's equally relevant in this day and age is CAT. Let's see what this says. For which value of k does the following pair of equations yield a unique solution of x such that the solution is positive? Two things, x has to be positive and unique. You will get a unique solution only when discriminant is 0. If you have discriminant which is greater than 0, you'll have two unequal roots, right? One of them might be positive, one of them might be negative, right? But for a unique solution, you'll need to have discriminant equal to 0, right? We are interested in x, so let's eliminate y from this. If I add these two equations, you'll get x square plus x minus k whole square equals 1. If you rewrite this, you'll get x square plus k square minus 2kx minus 1 equals 0, or 2x square minus 2kx plus k square minus 1 equals 0. What will be the roots of this equation? Root of this equation would be x will be 2k plus minus square root of the discriminant divided by 2. Now I want the discriminant should be equal to 0. So the root of this equation will be x is equal to k. So I want k to be positive, right? And discriminant should be 0. So if k is positive, this is out. When will the discriminant be 0? Let's calculate the discriminant. You will have 4k square minus 2k whole square minus 4 into 2 into k square minus 1 should be equal to 0. If I take out 4, you'll get k square minus 2k square plus 2 equals 0. If I rewrite this, you'll get k square equals 2, or k should be equal to plus or minus root 2. We have already eliminated root 2. So k should be equal to positive root 2. Option C would be our correct choice. So as you can see, if you understand the basic nature of quadratic equations, the questions are not very difficult to solve. As we discussed earlier with both progressions as well as indices search logarithm, quadratic equations are again a low hanging fruit which you should definitely solve. In algebra, don't spend over extra time trying to maximize or minimize inequalities, trying to learn arcane formula. These are the things, the basic relations between a quadratic equation. How do you find the roots of the quadratic equation, the nature of roots of the quadratic equation? That is more important than any of the other multiple relations or shortcuts that you learn in algebra. That completes this particular session. If you liked it, please do share it with your friends who are preparing for CAT and other MBA entrance examination. Please do subscribe to our YouTube channel as well as follow our Facebook page. The links for our course are available on the description to this video. Till we meet again the next time, goodbye and all the best.